Hello. Explosive news just dropped about 3I Atlas, and the scientific community is in chaos right now. November 4th, just hours ago, new reports emerged claiming the interstellar visitor has turned blue. Blue, folks. This would be the third color change in just 4 months, and here's the problem. This finding hasn't been peer-reviewed yet. No independent confirmation. We're looking at preliminary data that's sparking one of the most heated scientific debates of the year. Let me break down what's happening and why scientists are divided on what this actually means. The blue coloration claim comes from a preprint posted on October 28th that only got public attention in the last 24 hours. The researchers analyzed spacecraft data from when Atlas passed behind the sun near Perihelion on October 29th. Their conclusion: the object became distinctly bluer than the sun itself, suggesting gas emissions were contributing a massive fraction of visible brightness. This matters enormously because it's the third time we've seen Atlas apparently change color. Back in July, when it first entered our solar system, the object glowed red from surface dust being heated and released. Then in September, observations showed it shifting green, likely from cyanide or dicarbon molecules in its surrounding coma. Now we're seeing blue, potentially from carbon monoxide or ammonia outgassing as it passed closest to our star. But here's where the science gets messy. This November 4th report is based on a preprint that hasn't gone through peer review. That's the process where other scientists scrutinize the data, check the methodology, and either validate or challenge the findings. Right now, no independent telescopes have confirmed this blue coloration. We have one research team's interpretation of spacecraft data, and the broader astronomical community hasn't had time to verify what we're actually seeing. In science, especially when dealing with an interstellar object that's breaking every rule we thought we knew, that verification process is absolutely critical. You can't just claim a major discovery and expect everyone to accept it without rigorous checking. And this brings us to what happened just yesterday, November 3rd. Astronomer Chi-Cheng Zhang from Lowell Observatory in Arizona captured what are believed to be the first optical images of Atlas after it emerged from behind the sun. He used the Discovery telescope, one of the most powerful instruments that could point low enough on the horizon to catch the object so soon after perihelion. Zhang told reporters that Atlas is now visible to amateur telescopes across the northern hemisphere. All you need is a clear sky and a very low eastern horizon. It won't look impressive, just a smudge, but it's an increasingly visible smudge as it moves northward in our night sky over the next few days. The comet reached perihelion on October 29th, coming within 130 million miles of the sun, roughly 1.4 astronomical units. That's when the dramatic brightening occurred. Zhang's preprint notes that Atlas brightened by several orders of magnitude, far beyond what simple proximity to our star would explain. This rapid increase in brightness, combined with the reported blue tint, has scientists arguing about what's actually causing these effects. And this is where competing interpretations start clashing. One camp of researchers argues this is standard cometary behavior, just amplified by Atlas's unusual composition and trajectory. Comets heat up near stars. Ice sublimates into gas. Depending on what chemicals are present, you get different colors and brightness levels. Carbon monoxide or ammonia could absolutely explain blue coloration. Nothing extraordinary here, just physics doing what physics does. Thank you for being with us. Please subscribe, share, and like. But another camp, led by prominent scientists like Harvard University's Avi Loeb, sees something fundamentally different happening. On November 3rd, just one day before this blue color report emerged, Loeb published a comprehensive analysis listing 10 statistical anomalies about Atlas that he argues cannot be easily explained by conventional comet models. Let me walk you through the most significant ones because they're crucial for understanding why this debate has gotten so intense. First, anomaly: trajectory alignment. Atlas is moving in a retrograde orbit, opposite to how planets move around the sun. That alone isn't shocking. But this trajectory is aligned to within 5 degrees of the solar system's ecliptic plane. The statistical probability of this happening naturally is only 0.2%. Imagine throwing a basketball backwards through a hoop without looking. That's the level of precision we're talking about. Second, the sunward jet. Between July and August, Atlas displayed an anti-tail pointing directly toward the sun. This defies normal cometary physics. When comets approach our star, solar radiation pressure pushes material away, creating tails that always point away from the sun. But Atlas did the opposite. No known optical illusion or viewing angle explains this behavior. Third, the mass and velocity combination. Atlas is roughly 1,000,000 times more massive than Oumuamua, the first confirmed interstellar visitor from 2017, and 1,000 times more massive than 2I Borisov from 2019. Yet it's also moving faster than both objects. Larger objects typically move slower due to energy conservation. The probability of being simultaneously this massive and this fast is less than 0.1%. Fourth, perfect timing. Atlas arrived at the exact moment to pass within tens of millions of kilometers of Mars, Venus, and Jupiter, while becoming completely invisible from Earth during perihelion. The odds of this alignment happening by chance are 0.005%, 5 in 100,000. Fifth, metallic composition. Spectroscopic analysis revealed that Atlas has a much higher nickel to iron ratio than any known comet. Even stranger, this ratio resembles industrial metallic alloys we produce here on Earth. Natural comets have consistent metal proportions reflecting their birth environments. Atlas completely breaks this pattern. Sixth, water content. Comets are essentially dirty snowballs. Most of their mass is water ice. But Atlas contains only 4% water by mass. That's like finding an iceberg made of 96% rock. This challenges our basic definition of what qualifies as a comet. Seventh, extreme polarization. When starlight reflects off Atlas, it shows a negative polarization pattern never observed in any other comet, including 2I Borisov, which we know is natural. It's twisting light in ways that known natural materials simply don't do. Eighth, directional origin. Atlas came from a direction within 9 degrees of the famous WOW signal from 1977, that mysterious radio transmission many consider the strongest evidence of potential extraterrestrial communication ever detected. In interstellar terms, 9 degrees is remarkably close alignment. Ninth, this rapid blue brightening we've been discussing. The intensity and spectral characteristics are physically difficult to explain with normal cometary outgassing. And now the potential 10th anomaly, which could be confirmed or refuted in the next few weeks. The Atacama Large Millimeter Array detected non-gravitational acceleration in Atlas during perihelion. This means some force beyond solar gravity was acting on the object. Loeb's calculations show that if Atlas were producing this acceleration through normal cometary outgassing, it should have lost at least 15% of its total mass. We're talking about more than 5 billion tons of material that should be floating around it in a massive, easily detectable debris cloud. Here's the moment of truth, folks. December 19th, Atlas makes its closest approach to Earth at 168 million miles distance. If that predicted debris cloud exists, telescopes worldwide will spot it. But if we don't find that cloud, we'll have an object that accelerates without losing mass, which violates fundamental comet physics as we understand it. Now, things took a controversial turn that goes beyond scientific interpretation. High-resolution images of Atlas exist right now. NASA's HiRISE camera on the Mars Reconnaissance Orbiter captured the object on October 2nd and 3rd with 30 km per pixel resolution. These are the highest quality images of an interstellar object ever taken. But this data hasn't been released to the scientific community. On November 3rd, Loeb revealed he requested access from Professor Alfred McEwen at the University of Arizona, the principal investigator of the HiRISE team. He received no response. On the same day, Congresswoman Anna Paulina Luna submitted an official letter to NASA's acting administrator demanding immediate disclosure of these images. Loeb and many other scientists argue this data is time-sensitive. Atlas is leaving the inner solar system. The window to use this information for guiding observations is closing rapidly. Scientific data shouldn't be held hostage to bureaucracy, especially when we're potentially dealing with one of the most important astronomical discoveries in human history. The real fight isn't about whether Atlas is blue anymore. It's about data transparency, peer review standards, and fundamentally different interpretations of what we're observing. One side sees an unusual but ultimately natural comet from another star system. Strange composition, odd behavior, but everything explainable by physics we already understand. The other side argues we need to consider that Atlas might represent something outside our current framework. Not necessarily alien technology, but potentially a new class of object that doesn't fit our existing categories. When you have 10 statistical anomalies, each with probabilities below 1%, all present in a single object, the cumulative probability becomes extraordinarily tiny. Loeb emphasizes he's not claiming definitive proof of anything extraordinary. He's saying the scientific method requires following data wherever it leads, even toward uncomfortable hypotheses. History shows major discoveries came from questioning established thinking. Galileo was ridiculed. Einstein faced enormous skepticism. Breakthroughs happen when someone asks if maybe we're wrong about our assumptions. Critics counter that extraordinary claims require extraordinary evidence, and we don't have that standard of proof yet. Each anomaly might have conventional explanations we haven't figured out. Interstellar objects are rare. We've only confirmed 3 ever. Our models are based on solar system comets. Of course, an object from a completely different stellar environment might behave strangely. That doesn't make it artificial. The peer review process exists precisely for this reason. The November 4th blue coloration findings need independent verification. Other telescopes must observe Atlas and either confirm or refute these measurements. Alternative explanations need rigorous testing before we jump to exotic conclusions. But here's what both sides absolutely agree on. December is crucial. Between now and the 19th, telescopes across the northern hemisphere will have unprecedented access to study this object in detail. We'll analyze composition with spectroscopy. We'll search for that predicted debris cloud. We'll measure exact trajectory and acceleration. We'll monitor any brightness or color changes. We'll examine everything with instruments that couldn't see Atlas clearly when it was behind the sun. 2 European Space Agency spacecraft might even fly through Atlas's tail, collecting direct samples of shed material. That would provide chemical composition data beyond what spectroscopy alone can reveal. Zhang noted that Atlas is rapidly moving away from the sun's glare. Within a week, it should be 25 to 30 degrees separated, allowing numerous major telescopes worldwide to begin intensive observation campaigns. The window is opening right now. The next few weeks will generate a flood of research papers, observations, and data. Some questions will get answered. New ones will likely emerge. But we'll have a dramatically clearer picture of what Atlas actually represents. This November 4th blue color report, controversial as it is, highlights exactly why this object matters so much. Every observation reveals something unexpected. Every measurement challenges assumptions. Whether Atlas turns out to be a weird natural comet, something entirely new, or evidence that our models need complete revision, it's already forcing us to reconsider what we think we know about interstellar visitors. So what's your take on all this? Natural comet with extremely unusual properties? Something that fundamentally challenges our understanding? Is the scientific controversy healthy skepticism? Or are we watching a paradigm shift happen in real time? Drop your theories in the comments. And stay subscribed, because the next few weeks are absolutely critical. We're covering every major development, every new observation, every piece of data about Atlas as it comes out. December 19th is marked on every astronomer's calendar worldwide. The moment of truth is approaching fast. Thank you for being with us. Please subscribe, share, and like.